Hi guys, and welcome to another tutorial in Explain Mobile. Today I have the Boeing 737-800 and I'm going to demonstrate how to depart under IFR conditions from Daniel K. International Airport in Honolulu. IFR stands for Instrument Flight Rules, and they're basically rules that a pilot applies under the instrument meteorological conditions. So currently I'm at Daniel K. International Airport, which is on the main islands of Hawaii, which is Oahu if I'm not mistaken, and I'm currently taking off to runway 4 right, which is my runway for departure. Our weather conditions are cloud cover at 9,000 with heavy rains, and we have a slight wind of 9 knots on a heading of 160 degrees, and then we have a visual range of only 9.2 nautical miles. These are the main terminals of the airport where I'm coming from, where I've just taken off from. Alright, we'll continue turning to the right, but in these conditions, because the surface is very wet, we have to minimize our taxi speed to only 20 knots. Normally our taxi speed will be 35 knots in dry conditions. Alright, so I'm just keep the aircraft turning in order for me to get on the taxiway. Alright, with that being done, I'm going to do a short briefing before we depart this region. First thing we need to know is that right ahead of us there is mountains. So as we depart, we need to be very careful with that. And our V speeds are set on the mode control panel. Our V2 is 120 knots for departure, and V rotation will be 145 knots. Now, if you're not familiar with V speeds, basically when you're taking off, you have three different kinds of V speeds. You have V1, which is your decision speed, the speed at which our pilots can no longer make the decision to abort and take off. Then we have VR, which is speed, and then above that we have V2, which is the speed at which, if you have an engine failure, you climb it. It's called the one engine climb out speed. Alright, so during taxi, pilots are required to obey what is called the sterile cockpit rule, which says that they do not have to discuss anything that has nothing to do with the flight. So I'm going to do the briefing that we're going to follow, which is from 0 to 80 knots on our speed. We're going to stop if we have a slight emergency. That means any warning lights shows up in the cockpit, we have to abort the landing. Then from 80 knots to V1, we are only going to stop for a serious emergency, which include things like directional control, an engine fire, or a serious failure of hydraulic systems. Then once the aircraft has gone above V1, which is our decision speed, we can no longer make the decision to abort takeoff. In other words, even if above V1, we will have to take off with a failed engine, and we will have to request an emergency landing once the aircraft is airborne. So I'm just showing you around this region as well, and we're almost reaching the end of the runway, which is 4 right. In a distance there you can see the city of Honolulu, which is the capital city of Hawaii. So as we depart, we might be lucky enough to have a look at it. Alright, I think at this moment I need to swing the aircraft slightly to the left so that we can turn. Alright, I'm gonna start my turn right here. Alright, I'm gonna start my turn by swinging the aircraft all the way to the right. Alright, the turn has to be very gentle because of the wet conditions side of the surface. So it's going to be very slow. But anyway, everything else is set for flight. Our initial climb altitude will be 15,000 feet, and we're going to take a rate of climb of 3,000 feet per minute. Our runway heading for departure is 43 degrees. Flaps are checked, they are set to not set, but we're departing 15 degrees flaps. Whilst the flaps are in transition, I'll continue my turn to the right. In order to turn the aircraft, you use a device called a tiller, which is located next to the captain seat. It's like a little half steering that you use for for turning the aircraft. I'll just show it in a moment as soon as I'm done with this turn. Now, it seems like the aircraft is now picking up a bit of speed in order to turn faster. Alright, there we are, coming onto runway 4 right, which is identified on a heading of 43 degrees actually. Alright, there we are. Parking brake is set and the aircraft hold there. So this is the tiller, which is the device that you use for turning the aircraft. Alright, with that being said, we're going to do a short briefing and then we will depart the runway. First thing we need to do now is turn on landing lights, and then we need to switch off the taxi light, and then runway turn off lights can come on. Windscreen wipers should have been off, and then we check that engine ignition switches are set to continuous ignition. In the case one of the engine fails, it will try to relight itself up. And anti-ice is not required, so must be off. And we don't have warning lights illuminated on the mode control on the overhead panel. Alright, flaps are set to 15 degrees for departure. Speed brake is down, engine thrust levers are at idle, and we need to set auto brake to rejected takeoff. And we check the MCP, auto throttle is armed, flight directors are on, runway heading is set, initial cruise altitude is set, and vertical speed is set, and V2 is set, and traffic radar must be displayed. Yes, it is, by pressing traffic in the center there. And then I have flight path vector as well, and pretty much everything is done. Alright, so we are going to depart. I'm going to start my clock. The clock started. I'm going to bring engine power to 50%. 12 o'clock position. Make sure engines are stable. Then at this moment, I'm going to release our parking brake and go full power. Take off, go around, thrust. Airspeed is alive. We have a slight crosswind on 9 knots, so we need to take that into consideration. 80 knots check. V1 and rotate. We'll confirm we have a positive rate of climb, and we retract flap. We retract landing gear. I'll try and maintain a pitch of 15 degrees. I'll start reducing pitch in order to allow speed to climb. And we'll maintain runway heading until 1000 feet, and then we engage the autopilot. Alright, there we come, 1000 feet above ground, and autopilot can come in. First autopilot in command. Alright, we're going to select a vertical speed of 3000 feet per minute, and then we're going to go with MCP speed, mode control panel speed to 200 knots. And I'm going to confirm that on my primary flight display. MCP speed set, VOR lock, and vertical speed. I need to select LNAV for lateral navigation, and if you look down here at our flight management computer, you can see that we're now heading towards our first waypoint, which is OP, on a heading of 199 degrees, 17 nautical miles away. Now we've passed 180 knots, so I need to retract the flaps. Alright, now the speed is starting to climb, and we're going past 4,000 feet. Alright, after takeoff checklist, landing gear is retracted, flaps are retracted, and auto brake is set to the off position, and we're maintaining V2 now. So I'm going to increase speed to 250 knots, which is our speed limit below 10,000 feet. We're coming through 5,000 feet. And you can see the thick cloud cover just above us. At the same time, you can actually see the runway that we departed. The visibility is pretty poor under these conditions, right? Okay, now if you look at our mode control panel, we now have a speed indication at the bottom, which is saying 0.423. That's our true airspeed reading in terms of Mach. At the top, I have 250 indicated in magenta. That's our target speed. And if you look at the altimeter tape, we have 15,000 feet selected as our initial cruise altitude, which is equivalent to 4,835 meters above ground, and our rate of climb is 2,950 meters. Our barometer is set to 1,010 hectopascals, and our radio barometer is set to 420 for minimums, but we reset that as we are landing. Passing through 8,000 feet. We are now 2.2 minutes from OP, and I think we now passed through the cloud cover. So now we're now completely flying under IFR conditions. Alright, now I need to keep an eye on my primary flight display, because as we pass through 10,000 feet, I need to turn off landing lights and do the after takeoff checklist. We've now passed out of the cloud layer, and we are now above it with a beautiful sky above us. So this moment I am going to switch off the windscreen wipers because we don't need them anymore. Alright, now after takeoff checklist, landing lights must be off at 10,000. So we're passing through 10,000 feet, landing lights can come off, runway turn off lights can come off, engine ignition switches can go off, Alright, that is done, and the next thing we need to do is we pass through our transition altitude. We need to reselect our barometer to standard pressure. Our transition altitude is 18,000 feet. So that means at 18,000 feet we are now transitioning to flight levels, which means that as we climb from then on, any altitude above it will be referred in terms of flight level. For example, if we climb to 20,000 feet, it will now be regarded as flight level 200, and 21,000 feet will be flight level 210. Now in that region as well, we will now be flying under reduced altitude of vertical separation, which means at flight levels we need to maintain a vertical separation altitude with air traffic of 1,000 feet above or below us. Outside air temperature is now minus 12 degrees Celsius, so I'm going to turn on our anti-ice system. And now I'm going to try to match my heading with our trekking to the first waypoint, which is 199 degrees. Alright, there we are. Alright, there's the giant telling us that we're reaching our first initial cruise altitude. So now we're going to the next waypoint, which is Sabi, which is 6.1 nautical miles away, and we have estimated time en route of 1.1 minutes. I'm just going to increase our brightness because it feels dark in here. So increasing our instrument brightness, and as well as the overhead panel, I'm going to increase our brightness as well. Alright, there we go. So the aircraft is now in a gentle turn towards our next waypoint. Since we've passed 10,000 feet, I am going to increase my speed to 300 knots indicated airspeed. Alright, we're going to go to 300 knots. There we go, and if you look at our main display, shows that target airspeed is now 300 knots at the top of our speed tape, and you can see it with a little purple marker on the side. It's Mach 0.87, and it's still rising as well. Alright, so now we're going towards the next waypoint, which is Hotel November Lima, which is 32 nautical miles, and estimated time en route is 5 minutes. I am going to assume that air traffic control clearance to the next altitude, which is actually a flight level of 260. Alright, so I'm going to select a vertical speed of 2,500 feet per minute. That's because we are now at a very high altitude where the air pressure is very thin. So the performance of the engine obviously decreases, and I have to reduce my rate of climb as well. So as I mentioned, once we're passing through 18,000 feet, I'm going to reset our barometer to standard air pressure. Now you can notice that my indicated airspeed is holding constant at 300 knots, but our true airspeed is below at the bottom in Mach is increasing. That's because indicated airspeed is measured against air pressure using our pitot tubes. So as you go to higher altitudes where the pressure is lower, the indicated airspeed drops. But since true airspeed is measured against the real speed of the airflow around the aircraft, it always gives you the true measurement of the speed of the airflow. Alright, now we're approaching 18,000 feet. And our altimeter is set to 1010 hectopascals, so I'm going to reselect that by pressing standard on the barometer, and it's now in terms of standard pressure. So that means you're now at standard pressure altitude, which is flight level 180. Alright, having said that, we'll look at our next waypoint, which is Hotel November 100. It's 50 nautical miles and it's on a heading of 285 degrees. With that being said, the next part of our checklist requires us to check that seatbelt signs must go off and landing lights must go off and fuel pumps must be as required. Seatbelt signs are already off and we just need to check our fuel. We have 20.4 tons of fuel in total, 11.8 in the center, 4.31 in the left and 4.31 in the right. You can also see the rate of fuel flow, our oil pressure, oil temperature, oil quantity and vibrations. If I come here, our standby instrument indicator always shows our barometer in terms of inches. So even though the main primary flight display is showing standard pressure and it's been showing pressure in terms of hectopascals, our standby instrument indicator always shows it in terms of mercury inches. And so now we're passing through flight level 210 and we're still at 300 knots, but I assume by now our speed is increased. Our true airspeed is increased to Mach 0.676. I'm sure by the time we get to 26,000 feet, it should be around Mach 0.75, I believe. Alright, so we are 12.4 nautical miles from Hotel November Lima with estimated time en route of 1.7 minutes. And we are tracking 206 degrees. So I reselect that 206 degrees to match my heading. Alright, there we go. So the aircraft is continuing to climb and you can see that at 30,000 feet we have a sparsely populated cloud cover as well. And apart from that, there's not really much to see except the thick cloud cover that we left below and a visual range of 9.2 nautical miles. Alright, so coming down here, if you like, you can also select fix. So I can select a waypoint. For example, one that I normally use is Grammy. So I can select a fix, which is Grammy. Which I'll use, for example, if I'm under instrument landing system or an ILS, I would need a fix and I could set that. And look, it's showing me that Grammy, and estimated time to that is 0.09. I don't believe that's very correct, but anyway, there's a lot of things that you can actually do with this flight management computer. Checking on our progress page, we are going to Hotel November 100 and then our destination will be Papa Hotel November Yankee. So our climb, we didn't set any information regarding that, so I'll just leave it on the legs page. Our navigation radio is set to an ILS frequency of 111.70. Alright, so I think we've reached 26,000 feet, which is our initial flight level for cruise, and our speed is now Mach 0.34. So what I would like to do at this moment, I would like to select our speed in terms of Mach reading. So we're going to Mach 0.78, and you can see the auto throttle pushing the thrust levers forward in order to increase speed to that speed that we want. Mach 0.78 is indicated on our speed tape as our target speed. And soon we'll be climbing off to our next waypoint. Our true airspeed in terms of knots is now 467 knots. Alright, so what does our checklist say at this moment? It says that engine instruments must be monitored, fuel quantities monitored, and lights as required. And the next checklist will be the before top of descent checklist. Alright, so there you have it. I'm just going to enjoy my cruise from this altitude. If you notice in the back here, our inertial reference system is actually giving us our true coordinate system of this location that we are at. So those coordinate systems that you're seeing are the actual GPS coordinates for this location. So pretty much everything is set up for cruise. So I just enjoy this moment until I reach my destination and top of descent. Alright guys, I'd like to thank you all for just this tutorial as we departed Papa Hotel November Lima. I'll see you next time when I do another video in Explain Mobile. Thank you for watching guys. Goodbye.